Guys, this is Dr. Callahan with week 18 Wednesday. How are you guys doing? Go ahead and pause the video and answer the following questions. All right, so we have today, tomorrow, which is Thursday, and Friday, and then Monday, this coming Monday, you guys will be having your AP exam over in the Career Center at 8 a.m. Make sure you guys grab your number 2 pencils. Make sure your calculator, your TI-84s are charged and ready to go, and have a hearty breakfast, but not eating too much where you're stuffed and you can't think because you're overly stuffed. And also bring a bottle of water to make sure that you guys are good to go with that. All right, so with that said, today we're going to be talking about differentiation techniques. Specifically, we're going to talk about related rates when it comes to differentiation. And we'll just go ahead and get that started right now. So this is what you should have in front of you. If you don't have a copy of this, that's okay. You can just kind of follow along with the video and you can show your work on a separate piece of paper. Okay, I don't like that noise, which is really annoying. So I'm gonna go ahead and see if I can perhaps modify and change that. So give me 1 second. Okay, so let's take a look at the first question right here. It says a 15-feet ladder is sliding down a building at a constant rate of 12 feet per minute. How fast is the base of the ladder moving away from the building when the base of the ladder is 9 feet from the building? So how fast is the base of the ladder moving is what you are looking for. So I'm going to give you guys a second. Go ahead and take a look at the question. Get yourself acquainted with it. I would even recommend maybe give the question a try on your own first. Okay, so let's go ahead and take a look at this one. So some of the important facts that you should do is, one, I will recommend you drawing a diagram so that way you can see how this is going to be working. So you have a ladder. It's sliding against a building. And so this is just going to be designated by Y. And if that ladder is sliding over, we have the X right here. And just to be consistent, let's call the hypotenuse Z. So it says that the base of the ladder is 9 feet. It's saying 9 is X. And the 15 feet ladder and it's sliding down at a constant rate of 2 feet per minute. So here we have it. You have X equals 9. So you're looking at dx over dt, which is a changing of the x from the base of the ladder to the building. Y equals, which is dy over dt. I do know that that is changing at 2 feet per minute, so that's a dy over dt. And then I have z, which is 15, and that's dz over dt. Well, is the length of the ladder going to change? No, unfortunately, that's not. But the change of x will definitely be modified, and the change of y will definitely be modified because it's sliding down the building. Okay, so then looking at this, well, it looks like a hypotenuse, with a Pythagorean theorem. So let's just say x squared plus y squared equals z squared. And then I will have x squared, which is going to be the derivative, 2x dx over dt plus the derivative of y squared, 2y dy over dt equals 2z dz over dt. Let's go ahead and plug in some of the numbers in there. Now you know that x is going to be 9, dx over dt plus 2y, dy over dt is 2, 2 times 15 dz over dt, which is 0. All right, well, from there, let's just go ahead and algebraically solve this. 18 dx over dt plus 4y oh, and you know what? One thing that we could do here is you could find what y is, because remember, 9 squared plus y squared equals 15 squared. So that's going to be y squared equals 15 squared minus 81. So that's going to be 144. Y equals 12. Now the change of the ladder is going to be sliding down 2 feet per minute. So make sure you have a negative there. So then I'm going to go ahead and change the y to a 12. And the dy over dt is going to be a negative 2. So 24 times negative 2 is going to give me a negative 48. And then equal to 0. And then if I just go ahead and solve for this, dx over dt, which is a change of the base of the ladder. And since the question is how fast is the base of the ladder moving, that is what I'm trying to find. That's going to be positive 48 over 18, which is actually 8 over 3 feet per minute. And that is your answer. Okay, so I'm going to have you guys go ahead and give number 2 a try. Let's take a look at number 3. For number 3, it says a water is poured into a conical container at a rate of 10 centimeters cubed per second. The cone pointed down, and it has a height of 30. Oops. And a base radius of 10. How fast is the water rising when the water is 4 centimeters deep? So let's first start off drawing a picture of this cone. Okay, so water is pouring out of this. How tall is this cone? It says a cone pointed downward. It's a height of 30. So here we go. And then the base radius of 10. So then I can figure out that this part here, you can use the Pythagorean theorem if you need it. I also know that the volume of this container is changing at a rate of 10 centimeters cubed per second. And how fast is the water level rising when the water is 4 centimeters deep? So it's talking about how fast the water is rising. You're looking at the height of the water. So dH over dt. So from this diagram, I can go ahead and just slice off this tiny piece of the rectangle right here. I know that this is the height, and it is equal to 30. And then, of course, I have I should say this is height 1. And then, of course, you have this, let me change this a little bit. The entire thing here is going to be 30. This little piece here is the height. Here's your radius. And this piece right here is 10. So I could do R over 10 equals this little height over 30. So from here, 30r equals 10h, and the radius is equal to 10h over 30. So r equals h over 3. I also have the volume formula to utilize for this problem. Volume of a cone is 1/3 pi r squared, which is a circle, times the height. So I know that the radius is right here. I can't really solve for this if I have two unknown variables, but I do have the radius. So I'm going to replace that radius with height over 3 squared times height. So volume is equal to height cubed over 3 times 3, or actually in this case, it'll be 9. 9 times 3 is 27 pi. Or volume equals pi over 27 height cubed. So now let's go ahead and find the derivative of this. So derivative volume is dV over dt, which is equal to, remember the pi over 27 is just a constant. So pi over 27. Derivative of h cubed is just 3h squared dh over dt. Remember your goal is to find dh over dt, so I'm at least getting somewhere there. You also know that dv over dt is 10 centimeters, so I'll put 10 is going to equal to, I can go ahead and simplify this if I divide it by 3 on both sides. Oh, actually, you know what? Before I do that, I can actually even figure out what height is, because I know that my height is going to be hold on one second, let me see here. I know that my height is going to be 4 centimeters. So then if I plug it in right here, I have pi over 27. 4 times 4 is 16. 16 times 3 is going to be 54. dH over dt. And then, of course, I can reduce this if I divide it by 3. And then I can have a 16 over 9. And so let's solve for dH over dt, which will just be 10 times 9 over 16 divided by pi. So that's going to be a 90 over 16 divided by pi. Or if I divide it by 2 on both, it'll just be dH over dt equals 45 over 8 times pi. Centimeters per second. And that is your answer. Okay, so then with that said, go ahead and do number 4. I should let you know that the reason how I got the height right here is from this part right there that I did not underline. So sorry about that. All right, so let's take a look at the next part. Important theorems for you to consider. 1 is the extreme value theorem. 2 is the mean value theorem, MVT, and then the Rolle's theorem. So here are the conditions for that. Go ahead and take a look at it. Okay, so it's this number 1, find the value of the absolute extrema with this function on the interval -2 and 3. State the theorem and the conditions. Okay, so looking at this right here, if I find the first derivative of f of x, I'll have 6x squared minus 6x minus 12 equal to 0. Well, I can factor out a 6 equal to 0, and then x minus 2, x plus 1 equal to 0, so x equals 2 and -1. And both of those will be on the interval, so that's good. So I could use both of those as a critical point. So then I'll do f of, so that way you can check the height of each of these endpoints. So f of 2, f of 3, f of positive 2, f of -1, and you'll just plug it in here. So then f of -2 is a -3, f of 3 is a -8, f of 2 is a -19, f of -1 is an 8. So then looking at this, which one is going to be the highest and which one's going to be the lowest point? So you can say your absolute maximum is going to be at x equals -1, and your absolute minimum is x equals 2. And y equals 8, y equals, for this one, -19. All right, from here, I'm gonna have you guys just take a look at the remaining part of this with the Rolle's theorem and also with the MVT. And if you guys need some additional practice, keep in mind that the answers for this is gonna be right here. Here are the steps and the answers for everything that we kind of covered that was on applications of derivatives and related rates. If you need some additional practice problems, these are some of the questions that were featured on your AP Calculus multiple choice. If you need the steps, I have it right here. Next, I have the solutions for the 2015 multiple choice test. First part is a no calculator. Second part is a yes calculator. So let's go ahead and take a look at the no calculator portion. So if you go ahead and click on it, this is what it looks like for that test. And this is 2008 no calculator, 28 questions, 55 minutes, part 1. And you guys can go ahead and take a look at the steps shown for the question itself. I will highly, highly recommend that you guys go over these questions. The next one is the with the calculator portion. And 70 questions, 50 minutes, it's your part 2. And this is a good way for you to kind of compare and contrast the differences between the calculator and no calculators. All right, you guys, I think that is about it. Oh, week 18 Wednesday. So the last thing I want you to do is either go to this link right here, or you can use the 2 QR code. For week 18 Wednesday, watch an 8-minute video on tips on how to pass the AP exam. It's right here. List 3 strategies that you can learn and be applied from the video, and what should you be doing the night before the AP exam. I hope you guys have a wonderful week, and I'll see you guys next time. Take care.